Good afternoon. Sorry for the delay. We had some internet troubles, but hopefully we should be here good from here on out. Welcome to Module 3 of our webinar series on climate change data analysis using GIS tools. I am Marlene Tomaskevich. I serve as Regional Advisor for GIS for Climate Change Analysis at ESCWA. And this session will once again be moderated by Joël Lemaire, who will answer questions via the Q&A throughout this presentation. And some selected questions will be presented at the end to be answered live. This is a series of 6 webinar modules. Again, this is Module 3, and today we will focus on extracting tabular data from NetCDF climate files for use in other models and applications. Last week we introduced the NetCDF files and their use in an ArcMap platform. I hope you had the opportunity to complete the exercise by creating a raster from the NetCDF. And if you have not had a chance to view the webinar module or you're joining us for the first time, I encourage you to go back and view them available on our events page to get up to speed with the rest of us. Today we will focus on extracting time series data from NetCDF and how to extract daily climate data for a given location, which is helpful for inputting into other models and applications. And today we will also be using the ArcMap Builder for those who have never used it before, which will help us in terms of compiling multiple NetCDF files and time series data. Once again, I'll be referring to the training manual throughout this webinar, and it is still not quite available online. We're doing some edits, but it will be available shortly in both Arabic and English. And once it is online, we will let you all know via email. So last week, if you recall, we made a NetCDF raster layer. And when we got to the X and Y dimensions, you saw that the default values were n long and n lat. We changed these values to long for longitude and lat for latitude. Otherwise, the georeferencing of the resultant raster would have been incorrect. However, for this module, we will be using n long and n lat. So what is n long and n lat? Well, it's a numerical grid coordinate system. It originates at the domain in the bottom left corner. And n long is a number of grid cells in the horizontal direction. And n lat is a number of grid cells in the vertical direction. So for the 50 kilometer or 0.44 degree resolution, there are 232 cells in the X direction, the n long direction. And if we were to use the 25 kilometer grid data or 0.22 degrees, there would be double the amount of 464 cells in the horizontal direction. For the n lat, there are for the 50 kilometer grid resolution, there are 118 cells in the vertical n lat direction. And then for the 25 kilometer grid data, there are 236 cells in the n lat direction as well. So the coordinates, if we look at the 50 kilometer grid data, again, this is only for the Arab domain. The coordinates originate in the bottom left corner with a coordinate designation of 0, 0. If we move in the horizontal direction, we see that based on the number of grid cells, the coordinates change to 232, 0. If we move up, they go to 232/118 for the coordinates. And then if we go back to the top left corner is once again 0, 118. And these are the corresponding conventional latitude longitude coordinates for the same locations. Once again, this is only for the Ricard, Arab Ricard domain. Similarly, for the 25-kilometer grid data, the coordinates are the same concept, that is double, with 0.0 again at the bottom left corner, and then moving to 464, 0, 464, 236, and 0, 236 at the top left corner. Using these concepts, we can calculate to convert from latitude, longitude to n-long and n-lat coordinates. Is based on the, once again, the origin, 0, 0, and their resulting longitude, latitude coordinates to convert. However, the conversion for n-long and n-lat, they must be integer coordinates. They cannot have a decimal point. They cannot have negative values. So it is careful when you do conversion. Sometimes it doesn't always work because of rounding. Similarly, here's the equation for the 25-kilometer grid data. Uses the same concept with the grid resolution in the denominator, and in the numerator, the conventional longitude and latitude coordinates. Because of this rounding error that sometimes occurs, particularly if your data point of interest is near the edge of the grid cell, I have developed a shapefile to help you use to determine the n-long and n-lat coordinates of a location of interest. I provided the shapefile in the data set for today. It is also available on demand. So for example, if we want to know the n-long and n-lat coordinates of this location, we can click on the grid cell, select it, and then when we look at the table attributes, we see that for a latitude and longitude of 25.52 and 25.08, these are the centroid coordinates of that grid cell. The n-long and n-lat, n-long is 117 and n-lat is 73. One note, n-long and n-lat is not necessarily applicable to all climate data sets. Cortex datasets uses coordinate system known as r-long and r-lat, which are rotated coordinates. And we will discuss those further when we go to webinar module 5. N-long and n-lat is what we use for Ricard data, which is much more user-friendly. Once again, we'll be working with the multi-dimension tools. Again, last week we did the Make NetCDF raster layer, and today we will use Make NetCDF table view. And here is also that same tool in Arabic as well as the French versions if you are using ArcMap in these languages. Why would we want to use this tool? Well, as I mentioned earlier, it is to create time series data based on a point location, which is useful for hydrological models, or if we want to analyze projected trends based on the RCM outputs. So here's hydrological models. We would select all of the grid cells that are within the watershed. And then if we wanted to analyze trend data, such as seen here, it is helpful in that regard. One note of caution. ArcGIS is limited to creating tables for only one point location at a time. So if you wanted to analyze and get the data for all of these grid cells, you'd have to do each of them individually. I know for larger watershed basins, this might be a time-consuming task, but as you get more adept in doing this exercise, you will find that it turns out relatively quickly. There are tools that are available that will do time series analysis for an entire area, and we'll look at those at the end of the presentation. So let's take a little break here for a few moments before we move into using the tool. So once again, we'll be using the NetCDF table view. Each of these input parameters follow the same order in both the Arabic version as well as the French version. For this exercise, I will be showing you the location with our shapefile that I provided to you. Once again, we will be using extracted NetCDF files because of their large size, the same file we used last week based on Morocco. We will be, I've selected this location arbitrarily, which happens to have n-long and n-lat coordinates of 46 and 86. Like last week, when we use the Make NetCDF table view, we first input the NetCDF file we want to utilize and select its variable. Once again, we will be selecting PR for precipitation. Note that this tool can be applied for multiple variables, but this is not applicable for most climate data sets, including Ricard data sets. For the output table view, we can leave the default name as shown, or if you wish, you can user define. For row dimensions, we enter time. More than one row dimension can be selected. For example, if we happen to have elevation data within our NetCDF file, we can restrict based on a certain elevation. But this is not applicable to Ricard data sets and many other climate data sets. For the dimension values, we select n-long and n-lat. Although latitude and longitude data are included in our NetCDF file, it is not an option for Ricard data sets. So you will, if you do the drop-down box, you will not be able to select latitude and longitude. You'll only be able to enter n-long and n-lat. As I mentioned in the previous slide here, if we look at the entire Arab domain, we see that our location we want to study has an n-long and n-lat value of 46 and 86. However, because this is an extracted data set, we'll note that the range of values is limited. The range of values are from 0 to 34 for n-lat and from 0 to 36 for n-long. Thus, entering the aforementioned values would present a problem. As I mentioned earlier, the n-long and n-lat coordinates begin at the origin of the domain. So since our domain has changed because this is an extracted data set, it will begin at 0, 0 at the location I am showing. I have included the shapefile shown in green as well in your data set, so you can look at your location. So if we look at this location based on the extracted data set, we see that n-long and n-lat values are 24 for n-long and 23 for n-lat. The coordinates of the centroid remain unchanged because it's still the same location in terms of longitude and latitude. Thus, when we go back to our tool, the Make NetCDF table view tool, we see that we enter the 24 for n-long and 23 for n-lat. When you do this, you might be able to use the drop-down box, or you may have to enter the values manually. And again, they must be integer values, no decimals, and must be positive. If you enter otherwise values with decimals or with negative, you've done it incorrectly and that it will not work. So when we run the tool, we see that our results are as shown. We see daily values. Here's for January 1st, 2nd, 3rd, and we see our precipitation values, which are 0. You may get concerned about 0, but never fear. If we scroll down and we look at March 12th and March 13th, we see values of 6.01 for precipitation and 0.38 for precipitation on the following day. And because the data set is daily data again, this is millimeters per day. One word of caution if you use the 25-kilometer data set. They are formatted slightly differently than the more commonly used 50-kilometer data sets. These do not have n-long and n-lat values embedded in it. It will not be able to select them. Instead, you will enter the actual latitude and longitude coordinates for the dimension values, as shown here. So that same location, using the 25-kilometer grid data, the centroid value is minus 6.05 for longitude and 31.35 for the latitude value. And these are based on the centroid of the grid cell square, not necessarily on your actual location. So I show you this same location here. And you could see it, this is the coordinates of the centroid of that grid cell square. If we were to do that, the results would be also presented differently. As you saw in the previous results, it had negative values. However, using the 25-kilometer grid data, it will only present results that are non-zero values. So if we want to look at the entire time series, we must manually enter the 0 values, which are assumed to be on the dates that are not included. You know, for example, January 1st through January 10th would have negligible precipitation, 0 millimeters per day. And beginning on January 11th, we showed 7.53 millimeters per day. So, not many of you will use the 25-kilometer data other than for certain circumstances, but these are some key points that you must bear in mind if you happen to use the 25-kilometer grid data set. Last week we noticed that there were several questions on using QGIS, and the answer is yes, it is possible to use NetCDF files in QGIS. To perform the function of time series analysis, you must use a plugin, which is either the value tool or the GDAL2XYZ tool. For using the value tool, you must first load the NetCDF dataset by selecting layer and then add raster layer. And the results will appear similar to the graphics that are shown. One key reference that may assist is this training manual that has been developed, which for those of you who's using QGIS may find of use. If we were to use the GDAL2XYZ tool, we would select processing, then toolbox, then GDAL OGR, and then GDAL conversions. And it would be a process similar like this. And once again, I'm referencing for more information this training manual. So that is how we use to do one NetCDF file. But it's not very frequent that we would want time series data just for one NetCDF file, which would only be a single year, for example, 2046. To be able to compile data for multiple years, we will want to use the ModelBuilder. If you've never used the ModelBuilder before, here you clicked on this icon and you can see it is described and will be of assistance. To add tools and data to the ModelBuilder, we basically drag the tool into the ModelBuilder workspace. So we start off by dragging Make NetCDF Table View into our ModelBuilder. I discussed how to use ModelBuilder in our training manual on GIS to analyze climate change data in section 3.3.3. Next, we must select which NetCDF files we will use. I've provided you with 5 NetCDF files from 2046 to 2050 to use for this exercise. I recommend that you put them in a single folder by themselves, available on your desktop to do this. And to select these NetCDF files, we must select iterators and then select files. Here once again is how to find iterators and files on the Arabic version as well as the French version of ArcMap GIS. To iterate these files, we must select the entire folder, not a file, the entire folder as shown. If the wildcard and file extension are both optional, wildcard is if you wanted to restrict your data, if you happen to have multiple NetCDF files and you only wanted to select, for example, if you happen to have NetCDF files for precipitation as well as temperature and all in that folder, you might want to restrict your data only to precipitation files. So what you can do is select a portion of the file name, which would be a PR, and then you put an asterisk afterwards to restrict to only select those PR files. And then the option for file extension would be if we happen to have other files that were included. For example, if we happen to have a DBF file, you would put the file extension. But since all of our NetCDF files end with NC as a suffix, this is not applicable. So once again, we fill in our data using the NetCDF tool. We could select any of the NetCDF files that are in our folder to enter data. It is only used to temporarily enter data. Otherwise, it will not be able to read the file and understand exactly what data you need to enter. So you initially select one file and enter your appropriate parameters as you have done previously. Once you do that, your workspace will look as followed, and when the data is entered, the icons in the ModelBuilder will change from blank to colored. So rather than running the model just on that single NetCDF file to enter data, we need to use the connect tool to connect file to make NetCDF tool. And here is the icon that is used to connect. So the connect will literally drag from file to NetCDF table view to link those files. And then this blue oval will no longer be necessary, which was your initial file. So you can just simply delete it. It was here, and we have the file linked to NetCDF table view. And the results, if we look at table view, we will see that the input NetCDF file is file, and the variables are PR, as well as the remaining parameters remain the same as you initially entered. When we do this, the output will only remain in the memory, it will not be accessible for you to review. So what we need to do is to convert the output to a geodatabase table. We can find this tool, which is the table-to-table view, table-to-table tool, available under conversion tools and to geodatabase. And we'll drag this tool similarly to our ModelBuilder workspace. Here is that same tool, the table-to-table tool on the Arabic and the French versions of ArcMap GIS. For our output table, this is user-defined. I've elected to name my output as precip for precipitation. And following, you see this underscore, percentage sign, the letter N, percentage sign. This will designate our output to have each of our output be precipitation followed by a number in chronological order, starting with 0. Another option you can use is to name your output table as percentage sign, the word name, percentage sign name, percentage sign, and NAME, and that will name your output files the same as the input NetCDF files. So that is another option should you choose to do so. Because our file names are quite long, you may find this a little bit cumbersome with your results, but that's why I choose to name them precip with this percentage sign and percentage sign. And once again, the results will start with the number 0 and go up as high as needed. At this point, we will run our model. By selecting Run. We can see our results if we happen to open up the File Explorer. We will see all of our outputs as shown. If we did not designate to have them following by a number or by the parent NetCDF file name, they will continually overwrite each other. So it's important to choose one of these options with this percentage sign N or percentage sign name to avoid them overwriting each other. In the File Explorer, we'll see 3 different files with a suffix of CPG, DBF, and DBF XML. Each of these 3 files group together to create one geodatabase table. We can look at our output in Explorer just by opening up Explorer and selecting the DBF file itself, and we'll see the results as shown. This happens to be for the second file, because again, our results start with the number 0. This is for our second file for the year 2047, and we can see the results in Excel as we see here. Now, each of these tables are quite nice to look at, but you may want, particularly if you have the entire 150 years of data available for RECAR, if you want to have 150 years data, you do not want to necessarily look at every single year individually on its own. What you can do is combine them into one single table using what is called the Append tool. The Append tool is available under Data Management Tools, then General, and here it is Append. And again, here is where you find Append in the Arabic version, as well as the French version of ArcMap GIS. When we open the Append tool, we look at the results. For our input data sets, we use the drop-down box, and we will select that generic name that we once identified. And as I've been using for this exercise, it is precip underscore percentage sign, the letter N, percentage sign. Because our target data set must be based on an existing table, what I recommend to do is to copy your first file, and you must select each of these 3 files that are combined and just copy and paste it. And that will be our target data output, target data set. Again, we must select all 3 files and copy and paste them. I choose to leave the name as precip 0 -copy. But you can also rename it to whatever file name you may choose. When we run the model, it will keep this first file and append all of the new data sets following. So that's one thing to bear in mind. So when we look at our data output, because we used that first file for our append data set, we see that data for output for the year 2046 is repeated. So we'll disregard these first 365 entries so to avoid duplicating our data sets. Because the append tool will append to add on to existing data. And we do that, once again, to keep the file structure the same. Otherwise, the ArcGIS will not recognize the file structure and will not be able to conduct this tool. Once you've completed your model, you may want to use it again for other purposes, and you can save it, and it will be saved in your user toolbox. Accessing the user toolbox can be done from the ArcMap catalog screen on your ArcMap workspace. And to open up this model, what I recommend is to not use open, which would be normally expected. It will basically show an error. What you need to do for the model builder is select edit to open and run the model again after you've saved it at a later time. So again, the Make NetCDF tool will only work for a single point location at a time. And you cannot select multiple locations even using ModelBuilder. Believe me, I have tried. It does not work. So what I recommend if you need the output for an entire area is to calculate results for each grid cell individually and then keep all your results in a single Excel file. And then you can average those results or use those individual grid cells if you're inputting into a hydrological example, for example. There are alternatives out there which can do this. One is a tool called NetCDF Extractor. It is developed by a company called AgroMetsoft, and here is the link to access. This is a proprietary software, so you must purchase it. But I caution you, it's not very user-friendly. At least I find it not user-friendly. Another option is to use our Regional Knowledge Hub data portal, which you may find of assistance. However, the Knowledge Hub data portal, which we'll be talking about during Module 5, will average the results. And you can see the range of results in the blue shaded area, as well as the average, the mean, shown as on this orange line. So with that, I hope you enjoyed this webinar module, and as always, please feel free to send me messages. I know that some of you decided to show me your results from last week's module, which was fantastic. It's not necessary, but and all of you did very well. So nobody seemed to have trouble with the exercise from last week's module. And with any remaining time that we have, I'll ask Joelle to relay any questions that have been received during this session. Thank you.
Yes, so we have a question. Someone is asking about the data saved as text files, TXT. Can it be used in the ModelBuilder?
Yes, it would be entered similarly, but I'm not sure in what context you're using that, because it would not be able to be used for, I guess some TXT for data output. Perhaps, but it probably won't work. It will need to be a geodatabase for your output, but you could try. I mean, some versions may be different, especially more recent versions that may be compatible. I'm once again using version 10.6, and I'm unable to use TXT files, but perhaps if you have another version, you might be able to do that.
Okay, we have another question. Comparing the slide 19 and slide 26, someone is asking, why have the values of nlon and nlat changed, even though it's the same location?
Okay, once again, and I understand this is a little confusing.
It's on mute.
Once again, I understand that's a little confusing. So the nlong and nlat values are defined based on the domain. So here is the entire Arab domain. Here's the entire Arab domain. So for the origin for this domain is here, approximately here, which is 0, 0. And our nlong and nlat values are based on this origin at the origin bottom left corner of this domain. Because, let me find that other slide. Because for the extracted data set, the domain for has been reset. So because it's extracted, this is our new domain. It's approximately a rectangle like as shown. And our origin here has changed because it's now extracted. So it will start from 0, 0 at this location instead of down here. So for the most part, you'll be not using extracted data sets unless you happen to extract them yourself using CDO, or if we're based on a data request, you need extracted data sets for a particular purpose. So for the most part, you'll be using data for the entire Arab domain. But I've included both of these shapefiles in our exercise data set for your reference. Thank you.
Okay, someone is asking, in case you work with a resolution of 12 kilometers, how to calculate nlat and nlong?
Okay, so if we're using the 25-kilometer data set, which I believe we're talking about, we use a similar equation as the previous one. Here's the equation for 44 degrees. And all we've done is change the grid square size, which is 0.22 degrees. So here's the equations. But again, because the 25-kilometer data set is formatted slightly differently, you will be actually entering the longitude and latitude coordinates of the grid cell centroid rather than the nlong nlat values. And I've provided the shapefile for the 25-kilometer grid data set to help you determine what the latitude and longitude coordinates are for your location of interest.
Okay, there's one last question about working. It's a general question on ArcGIS. It's about finding a symbology scale that fits all resulting grids beyond the minimum and maximum. So, like the participant is asking for a single symbology scale for all grids that could work on all grids.
When you use ArcMap GIS, you can define it by the symbology by right-clicking on the table of contents and selecting on your shapefile, and you can select symbology by selecting properties. So, I mean, I happen to, when I open the shapefile, which is the Arab domain grid cell file, I left it as the default value of purple, this light purple color, but I could have selected symbology that I wanted to, if I wanted to make this yellow or another color. The color is not saved with the shapefile itself. It's not directly embedded, but if you save your entire ArcMap project, it will retrieve the color that you saved it as. But if you happen to reopen it into another ArcMap project, it will not necessarily retain that symbology. So you have to define it in an ArcMap project and then save the project to be able to retain the symbology. Okay, well, thank you very much. I hope you enjoyed today's webinar. If you wish, feel free always to contact me if you have any questions. And I hope you join us next week. We had over 500 registrants registered for today's webinar, and we saw from all across the Arab region attending in the Q&A and beyond. So welcome, welcome. Thank you very much, and have a good rest of your week. Thank you.